Okay, so in question 5, during a fire extinguishing operation, a helicopter remains stationary, hovers above a dam while filling a bucket with water. The bucket of mass 80 kilogram is filled with 1,600 kilograms of water, is lifted vertically upwards through the height of 20 meters by a cable at a constant speed of 2 meters per second. The tension in the cable is 17,000 newtons. Assume there is no sideways motion during the lift and air friction is ignored. State the work energy theorem in words. The total work done is equal to the change in the object's kinetic energy. That is true. The total work done is equal to the change in kinetic energy. I would rather just say the net work done is equal to the change in kinetic energy. But total, if you mean it in that sense of summing it, then sum is positive, sum is negative. But I think it's better for your own understanding just to say the net work done is equal to the change in the object's kinetic energy. Draw a free body label diagram showing all the forces acting on the bucket while it's being lifted upwards. Okay, very good. There's an upwards force applied. There's a downwards force of friction and a downwards force of the weight. Perfect. Use the work energy theorem to calculate the work done by air friction on the bucket of water after moving through a height of 20 meters. Okay, so let's see what the student did here. Excellent. So we've got our net work is equal to change in kinetic energy. The work done by the applied force is 17,000 times the displacement, which is 20, times of cos, because it's moving upwards, there's an angle of 0. Good. Then the work done by friction, this again Afrikaans students is wrijving. Work done by friction is the one I'm trying to work. Okay, so no, sorry, I lied. This is the work done by the weight. Okay, I use work done by gravity, WG, is mgh. So it's mass times gravity times height. So it's mass of 1600. Does it look like a 1600? That one's like 1680. Yeah, I hope that's a 0. It would be annexing. Mass times gravity times height. You'll see he puts in a cos of 180 because it's moving in the opposite direction of motion. Myself, I just prefer putting a negative in front. So when I do this, I say I change the signs here and ignore the angles if it's positive or negative. Because I'll look at what is my income forces. I've got tension is income because it's pulling in the same direction. I've got work done by weight is a expense force or an expense energy because it is downwards against my motion, and friction as well. And so then there's work done by friction. And then let's just see if that was a mistake. 1,600 times 9.8 times 20 is 31. Yeah, I think he said 1680. But listen, I might not. Okay. See. He's smarter than I. He remembers an 80 kilogram mass of the bucket. Isn't that brilliant? Well done, student 1. You're doing phenomenal. Phenomenal. Well done. Okay. So, yes, and I see no reason. At a constant speed. Good. Good, on this side has to be 0 because it's at a constant speed. So, absolutely fantastic. I can't see any reason why that answer wouldn't be correct. So, well done. That's question 5. That was a very easy energy question. Usually they're quite a bit more difficult. But well done for how well you answered this one.